So in today's video, we are going to continue our lesson on trigonometry. In this video, we will focus more on trigonometric ratios. Now, in the previous lesson, we said that given a right-angled triangle, assuming this angle is angle theta, the longest side of the right-angled triangle is called the hypotenuse. So we have this to be the hypotenuse. And then the side opposite the angle is the opposite. That is the opposite side. And then beneath the angle, we have the adjacent. This is the adjacent. Now we also made mention of SOHCAHTOA. The S stands for sine, which means that for this case, we have sine theta equals opposite over hypotenuse. So the opposite side over the hypotenuse. And then we have C standing for cosine. So cos theta equals adjacent over hypotenuse. And then we have tan. Tan theta equals opposite over adjacent. So this is just a recap of our previous lesson. Now let's move ahead and solve some questions involving trigonometric ratios. So let's try our first example. Example 1. If 4 tan x is equal to 3, where 0 is less than or equal to x is less than or equal to 90, I find x, I evaluate 1 plus cos x over 2 minus cos x. So let's try this question together. So we are going to find x given that 4 tan x is equal to 3. So 4 tan x is equal to 3. And we divide through by 4. So that we have tan x equals 3 over 4. Now this is the same as tan x equals 0.75. And then because we want to find x is equal to tan inverse of 0.75, and this gives us 36.87 degrees. So this is the value of x, 36.87 degrees. Now let's evaluate 1 plus cos x over 2 minus cos x. So from I, we have tan x to be 3 over 4. That is from here. We have tan x to be 3 over 4. Now according to SOHCAHTOA, tan is opposite over adjacent. So the 3 is the opposite side and then the 4 is the adjacent side. So now let's draw the right angle triangle. So we have our right-angled triangle. This is angle x. The opposite side is 3. The adjacent is 4. And then let the hypotenuse be y. So we are going to find y, the value of y. So y squared is equal to 4 squared plus 3 squared. According to Pythagoras theorem, we have y squared equals 4 squared is 16 plus 3 squared is 9. Now this gives us 25. So y is equal to the square root of 25, and then y is equal to 5. So we have the value of y to be 5. Now we are going to find cos x. Okay, we are going to find cos x. So cos is adjacent over hypotenuse. Adjacent over hypotenuse. So we have the adjacent side to be 4 divided by the hypotenuse, which is y, and that is 5. So we have 4 over 5. That is cos x. Now we are going to substitute 4 over 5 in place of cos x so that we can find the value of this expression. So we have 1 plus cos x over 2 minus cos x. And then we had cos x to be 4 over 5. So this is going to be 1 plus 4 over 5 divided by 2 minus 4 over 5. So this is 1 over 1. We can write this as 2 over 1. So let's simplify. Now the LCM between 1 and 5 is 5. So 5 divided by 1 is 5. 5 times 1 is still 5. 5 divided by 5 is 1. 1 times 4 is 4. Divided by the LCM between 1 and 5 is 5. 5 divided by 1 is 5. 5 times 2 is 10. Minus 5 divided by 5 is 1. 1 times 4 is 4. So this becomes 5 plus 4 is 9. So 9 over 5 divided by 10 minus 4 is 6. So 6 over 5. And then this is equal to 9 over 5 times, we take the reciprocal, that is 5 over 6. 5 goes here once, goes here once. 3 goes here 2 times, 3 goes here 3 times. So we are left with 3 over 2, which is the same as 1.5. So 1 plus cos x divided by 2 minus cos x is equal to 3 over 2, or better still 1.5. Now let's take the second example. So for example 2, if sine x is 8 over 17, find the value of tan x over 1 plus 2 tan x. Find the value of tan x over 1 plus 2 tan x. Let's solve this question together. So we are given sine x to be equal to 8 over 17. Now, like we did in the previous example, let's draw the right angle triangle. Now, according to SOHCAHTOA, we have sine x to be opposite over hypotenuse. So this is the angle x. So opposite to the angle we have 8, and then the hypotenuse is 17. Now let the adjacent side be y. Now let's find the value of y. So according to Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the two sides. So that is y squared plus 8 squared. 17 squared is 289 equals y squared plus 8 squared is 64. We transpose this to the left hand side. We have 289 minus 64 equals y squared. And then this gives us 225 equals y squared. So we take the square root of both sides, and then we have y to be equal to 15. So the value of y is 15. That is the adjacent side. Now since y is 15, let's find tan x. So we have tan x to be the opposite over the adjacent. So opposite over adjacent. The opposite is 8. The adjacent is 15. Now let's substitute 8 over 15 in place of tan x into this expression. Therefore, tan x over 1 plus 2 tan x is equal to 8 over 15 divided by 1 plus 2 times 8 over 15. Now let's simplify. We have 8 over 15 divided by 1 plus 2 times 8 is 16. So 16 over 15. We can write this as 1 over 1. Let's simplify further. So we still have 8 over 15 divided by, the LCM between 1 and 15 is 15. 15 divided by 1 is 15. 15 times 1 is still 15. Plus 15 divided by 15 is 1. 1 times 16 is 16. So this is equal to 8 over 15 divided by 15 plus 16 is 31. So 31 over 15. So we had tan x over 1 plus 2 tan x to be equal to 8 over 15 divided by 31 over 15. So this can be simplified as 8 over 15 times 15 over 31. We take the reciprocal, and then 15 goes into itself once, into 15 once, and then we are left with 8 over 31. Therefore, tan x over 1 plus 2 tan x is equal to 8 over 31. So for example 3, from sine x equals 1 over 2, where 0 degrees is less than or equal to x is less than or equal to 90 degrees, evaluate sine x cos x over cos x plus tan x. So we are going to evaluate sine x cos x over cos x plus tan x. Now given that sine x equals 1 over 2, we are going to draw the right angled triangle. So we have this angle to be x. Sine is opposite over hypotenuse, so the opposite side is 1, the hypotenuse is 2. Now let's find the adjacent. So we have 2 square equals y square plus 1 square. 2 square is 4, so 4 equals y square. 1 square is still 1. Let's transpose 1 to the left hand side. We have 4 minus 1 equals y square, and then y square is equal to 3. We take the square root of both sides, and then we have y is equal to the square root of 3. So this is the value of y. Now in the expression we have cos x and then tan x. So let's find cos x and then tan x. So we have sine x to be 1 over 2. Cos x is equal to adjacent over hypotenuse. So the adjacent is square root of 3 over the hypotenuse is 2. And then for tan x, we have opposite over adjacent. So that is 1 over root 3. However, we need to rationalize this. So this is equal to 1 over root 3 times root 3 over root 3. So we multiply top and bottom by root 3. Now this is equal to root 3 divided by root 3 times root 3 is root 3 square, which gives us 3. So this is the value of tan x, root 3 over 3. We have cos x and then sine x. So let's substitute all these values into this expression. So we have sine x cos x over cos x plus tan x. So that is equal to sine x is 1 over 2 times cos x, we have root 3 over 2 divided by cos x is root 3 over 2 plus tan x is root 3 over 3. Let's simplify. So 1 times root 3 is root 3 divided by 2 times 2 is 4 divided by the LCM between 2 and 3 is 6. 6 divided by 2 is 3. 3 times root 3 is 3 root 3 plus 6 divided by 3 is 2. 2 times root 3 is 2 root 3. Now let's simplify further. So we got to the point where we had root 3 over 4 divided by 3 root 3 plus 2 root 3 divided by 6. So this becomes root 3 over 4 divided by 3 plus 2 is 5. So 5 root 3 divided by 6. We can simplify further. We have root 3 over 4 times 6 over 5 root 3. So this goes here once, 2 goes here 2 times, 2 goes here 3 times. So we are left with 1 times 3 is 3, 2 times 5 is 10. Therefore, sine x cos x divided by cos x plus tan x is equal to 3 over 10, or better still 0.3. So for example 4, given that cos x is 3 over 5, where 0 degrees is less than x is less than 90 degrees, calculate without using mathematical tables or calculator. Calculate 3 tan x divided by 2 sine x plus 3 cos x. So we are given cos x to be 3 over 5. Let's draw our right angle triangle. Cos is adjacent over hypotenuse. So we have adjacent to be 3, hypotenuse to be 5. Let the opposite side be y. Now let's find the value of y. So we have 5 square equals 3 square plus y square. 5 square is 25 equals 3 squared is 9, so plus y square. We transpose this to the left hand side. 25 minus 9 equals y square. We have y squared to be equal to 16. Now we take the square root of both sides and then we have y to be equal to 4. Now this is the value of y. Now since we have sine x and then tan x in here, let's find the values of sine x and then tan x respectively. So we have sine x, sine is opposite over hypotenuse. So opposite is 4, hypotenuse is 5, and then tan x. Tan is opposite over adjacent. So we have the opposite to be 4 and the adjacent to be 3. So that is 4 over 3. And then we have cos x to be 3 over 5. So now let's calculate 3 tan x over 2 sine x plus 3 cos x. So this is equal to 3 times 4 over 3 divided by 2 times 4 over 5 plus 3 times 3 over 5. Now this is equal to 3 cancels out 3. We are left with 4 divided by 2 times 4 is 8. So 8 over 5 plus 3 times 3 is 9. So 9 over 5. Now this is equal to 4 over. Now because the denominators are the same, we are going to add the numerators. So we have 8 plus 9, which is 17. So this is equal to 17 over 5. So we have 3 tan x over 2 sine x plus 3 cos x to be equal to 4 over 17 divided by 5. So we can further simplify this as 4 times, we take the reciprocal, that is 5 over 17. And this is equal to 4 times 5 is 20 over 17. And then we can convert this to mixed number form, that is 1 whole number 3 over 17. So this is the value for 3 tan x over 2 sine x plus 3 cos x. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.